you will find electronics almost in every possible thing,
Yes.
which is already happening, right?
Yes.
You can find chip in almost everything.
Yes.
That means it is omnipresent, and
Yes.
it's only going to increase.
Okay, so I need to generate at least 1000 engineers.
We need even more.
Hello everyone, I am Vaibhav and आज मैं आपका host हूँ, right? So we have Mr. Rohith and he is currently a country manager for an embedded group. Okay, welcome sir.
Thank you.
Okay. So before starting the session, मैं कुछ बात करना चाहूँगा कि मैंने भी अपना करियर FPGA से स्टार्ट किया था और 2014 में जब मैंने क्विट किया तो मुझे सर आपके साथ काम करने का मौका नहीं मिला. ओके, लेकिन मैं आज के इस हर मोमेंट को आपके साथ एंजॉय करना चाहता हूँ क्योंकि मुझे आपके अंदर एक बहुत अच्छी एनर्जी दिखती है जो मुझे बहुत मोटिवेट करती है कि यार काश मैं आपके साथ काम करता.
Very nice.
ओके, सो 2014 के बाद जब मैंने ये अपना काम शुरू किया तो सर मैंने FPGA में ही अपनी पहली R&D स्टार्ट की एंड देन इट्स मोटिवेटेड मी टुवर्ड्स सम एकेडमी एंड नाउ थिंग्स आर like this ki yes, I am still a part of FPGA company and still the customer whom we have interacted during my application, they are still calling me and taking the support. So thank you sir, thank you थोड़ा सा टाइम देने के लिए. ओके, सो सर जैसे कि हमें ये एक सेशन है हमारा तो बेसिकली ये सेशन मेनली हमें अपने जो यंग इंजीनियर्स हैं उनको सोचकर मैं बनाना चाह रहा हूँ. बेसिकली हमें आज की FPGA पर क्या एप्लीकेशंस हैं, क्या ट्रेंड है और करियर पॉइंट ऑफ व्यू से कैसे FPGA इम्पॉर्टेंट है, ये सब चीज़ें बहुत ज़रूरी है जो मैं तो शेयर करता ही रहता हूँ. लेकिन आप अगर आज इस प्लेटफॉर्म पे शेयर करेंगे तो उनको एक मैसेज मिलेगा कि FPGA पे क्यों आना चाहिए, अपने डोमेन की तरफ क्यों आना चाहिए.
Correct.
वो जो इलेक्ट्रॉनिक्स में डिजिटल पढ़ रहे हैं and they are not aware of the programming language, they know the C, they know the Java, they know many things, but they are not aware of HDL, okay, Verilog, VHDL, and they don't know how this C and embedded C is working on FPGA. Okay, so मैं तो शेयर कर रहा हूँ, मैं चाहूँगा आपसे भी आज ये इन्फॉर्मेशन दें, लेकिन बहुत डिटेल में जाने से पहले सर मैं ये जानना चाहता हूँ कि आपकी जर्नी, कि आपका नेटिव प्लेस क्या है एंड आपने 10th एंड 12th में मतलब कैसे सोचा कि इंजीनियरिंग चूज़ करनी है या बायो जाना है. सर ओवर टू यू सर.
Thank you, Vaibhav. So before I talk about my journey, I have been quite inspired by you.
Thank you sir.
We first met a couple of years back, and since then you've always, inspired in terms of the way you want to create the new batch of engineers, right?
Yes.
Who are especially looking towards the electronics domain. So that's a big inspiration for me also.
Thank you.
So my journey, I started, I was born in Mysore,
Okay.
right? So good part of my childhood was all spent in Mysore. After my 12th, I moved to Bangalore for my engineering. Studied in PES Institute of Technology. Now it's called PES
Okay.
Group
Okay.
University. Post that I was employed in Texas Instruments. I was there close to 9+ years.
Okay.
And then it has been the last 9 years in Xilinx, which is now AMD.
Okay.
So this is my 18th year in semiconductor industry.
ओके सर, मुझे याद है मैंने आपसे बहुत पहले बात की थी तो एक मन में मेरा हमेशा एक क्यूरियस रहा, एक क्वेश्चन रहा कि मैं सभी इंडस्ट्री लीडर से पूछता हूँ. ओके, और ये क्वेश्चन जाना चाहिए बच्चों में. आजकल के ट्रेंड क्या है कि बच्चे लोग CS की तरफ जाते हैं, EC ले लेते हैं, लेकिन उनको मन में होता है कि यार अपॉर्चुनिटी तो CS में ही है. ओके, तो मेरा हमेशा 95% IC के 90-95% बच्चे CS IT की तरफ ही मूव करते हैं. तो सर उस टाइम पर आप ने जब B.Tech की तरफ जा रहे थे तो आपके मन में क्या था कि आपको EC लेना था कि आपको CS लेना था कि आपके पेरेंट्स ने आपको बोला कि क्या लेना चाहिए?
So my journey towards electronics started even before engineering.
Okay.
After I cleared 10th, just like all the other kids, I also took PCM-B, biology.
Okay.
So that I
biology.
have,
Oh,
so that
maths
I
and
have,
biology.
exactly, so that I have option of, going both the streams,
Okay.
right, engineering or medical. so what happened was I could not do so well in the beginning, right? I was attending classes, but it was so difficult for me to manage the lab. You know, simple example I'll tell you. You have to remove the peel the onion
Okay.
and then put it under a microscope and see it,
Okay.
right? How the stem cell is. I was really struggling to even manage that.
Okay.
So it is my inability to do biology which put me in electronics. That's just on a lighter vein. But actually, electronics did inspire me even before, right? Just like all the other, I would say, kids of that age,
Okay.
coming from a small town.
Yes.
You're used to fiddling around with transistors, fiddling around with the Yagi antenna in a dish TV. Whenever you get a small toy, you're like open up the battery and see how the motor works and things like that. So I have been kind of quite curious from beginning. Uh, but the seriousness of looking at electronics really came when I was in the 11th and 12th. And like I said, initially it was a kind of an accident that I decided not to do biology. So I really went to my professor in the college and I said I want to do electronics. He was not very convinced with my request, but after I completed 2 years, when I was able to secure a very good marks, I actually got 100 out of 100 in the electronics
Oh,
in 12th. That's
great.
when he said, you didn't make me regret my decision,
Great, sir.
right? So it was even before I joined B.Tech that I had decided that I will be in the electronics field.
Great, sir. Great to know, sir. अगर उस टाइम पे अगर वो ओनियन हो जाता
वो
तो
peel हुआ होता तो I would have probably been a doctor.
Yes.
In fact, my
Dr.
parents
Rohith.
wanted me to be a doctor.
Yeah, Dr. Rohith looking good, sir. ग्रेट सर. तो मतलब दिस इज़ क्लियर कि आप पेरेंट्स से मतलब आपके पेरेंट्स ने आपको नहीं पुश किया कि आप बेटा इलेक्ट्रॉनिक्स लो या बट हाँ उन्होंने आपको एक रास्ता दिखाया कि आपको इंजीनियरिंग करना है. ओके. तो सर एक बहुत अच्छा क्वेश्चन है आज की डेट में. मैं ज़्यादातर बच्चों से पूछता हूँ कि आप लोग प्रोजेक्ट क्या कर रहे हो. ओके. तो मैं उसमें नहीं जाना चाहता कि वो प्रोजेक्ट कहाँ से करते हैं क्या करते हैं. सर उस टाइम पर आपने किस तरह के प्रोजेक्ट्स किए थे जिसने आपको हेल्प किया कोर में जाने के लिए.
Okay. So, my first 2 years of engineering went very ordinary, similar to any other students, right? I was staying in a hostel in Bangalore because my parents were all in Mysore. So I was in Bangalore and I was staying in hostel and I had really good hostel mates, my seniors, who inspired me. Some of them are preparing for their masters in electronics. And we used to spend quite a good amount of time in their rooms and seeing what they are trying to learn. They were preparing for gate exams, things like that. So naturally I was quite taken towards the analog electronics, digital electronics, fundamentals of it.
Okay.
And I started attending all these college fests.
Okay.
Right, at that time it was a
Technical
big
fest.
technical fest, which was a big thing during that time where you were presenting papers, right? So me and one of my friend, we both presented multiple papers on I remember one of them was MRAM, right?
Okay.
Magnetoresistive random access memory.
Okay.
And then couple of other technical papers which we used to sit and write and then present these in technical fests, and in some places we got good awards, right? Which also started to make us feel, hey, look, I think there is a path in this domain rather than going towards computer science. More than now, when I graduated in early 2000s, computer science was actually exploding, right? There was so much more jobs. There were not so many electronics jobs like now during that time because not so many companies were there.
Somewhere around 2006-7.
Around 6-7.
Okay.
So 2006 is when I was getting into all these placement interviews. There were more computer science jobs during that time. So naturally the interest will be, hey, let us first secure the job.
Yes.
But all these things like winning good awards in paper presentation, I also had the opportunity to have internship at one of the DRDO organizations.
Okay.
Where I actually worked on FPGAs.
Okay.
And that experience was very enriching. So all these combination factors made me stick on with my
with a core
core engineering
course.
stream rather than switching and going towards
Okay.
electronics.
Great.
Initially, I would say it was a bit of a hard time because you can clearly see the path in which your compensations grow
Mm.
very quickly in computer science. But I would say over a period of time, uh, I think I did the right thing of
Yes.
sticking on with the core stream.
Yes. I think, sir, that was your like a changing, like you decided to switch to first core domain, correct?
Yeah.
So, okay, everyone, just be with us. अभी हम लोग सर के साथ तो सर की जर्नी के बारे में डिस्कस कर रहे हैं. ओके, थोड़े टाइम में आपको पता चलेगा कि क्या अपॉर्चुनिटीज़ है एफ के अंदर. एंड यस, बहुत सारे बच्चे मुझसे पूछते हैं सबसे पहले कि इससे चैलेंजेस नहीं, पैसे बताओ, क्या सैलरी है. ओके, तो वो भी हम डिस्कस करेंगे. सो बी विद अस. ओके, थोड़ा सा हमें सर को समझने दो कि सर के साथ कैसा जर्नी रहा है. ओके, तो सर यही था आपके साथ, मतलब आपने मतलब जो आपकी फर्स्ट जॉब थी, जो मैंने देखा है, यू स्टार्टेड योर जर्नी विद टीआई.
Yes.
And you started with like an associate engineer.
Correct.
Okay, and you moved to Dallas,
Correct.
USA. Okay, तो सर वो 4th ईयर और वो डलास के बीच में क्या जर्नी थी, वो थोड़ा सा.
Absolutely. So like I said, I did my internship in DRDO organization, which was building radars, and I worked on
Okay.
FPGAs.
DRDO
Yes,
as a intern,
as an intern.
pre-final year or final year?
Final year.
Final year.
Yeah. So
Okay.
our internship is typically in the last year.
Okay.
So before joining TI, I was doing internship there, right? Internship/project.
Okay.
We also have this project submission.
Okay.
So that was the time when, interestingly, TI came out with this program where they were actually rotating students within their organization for different jobs, right? They will usually hire a bunch of students
Okay.
and then they move all of them to their HQ, which is in Dallas,
Okay.
and they call it rotation program.
Okay.
In which they'll put few people under application engineering, some people under marketing, some people under fabrication team and different teams.
Okay.
And then depending on how they will perform, they will get absorbed in those departments,
Okay.
right? So that is when I moved in one of the groups. I was in the sales group.
Okay.
I was actually in the marketing group.
Okay.
In
Technical
TI,
marketing.
technical marketing
Okay.
group in Dallas.
Okay.
Further, after the program was completed, I moved back to India.
Okay. So, one thing I want to tell you guys, this technical marketing is not, don't consider that this is a marketing job. Okay. प्रोडक्ट वही सेल कर सकता है जिसको टेक्निकल नॉलेज होगी.
Absolutely.
ओके, एंड the technical marketing in our domain is totally very challenging, just like people who is designing the product, because जो डिज़ाइन टीम ने जो बनाया है, अगर उसको कस्टमर के रिक्वायरमेंट के अकॉर्डिंग कोई पिच नहीं कर पाएगा, देन इट इज़ टोटली वेस्ट.
Correct.
सो सर, मैं भी खुद इस डोमेन से हूँ, मुझे पता है कि कितना चैलेंज होता है टेक्निकली एक साइंटिस्ट को, एक इंजीनियर्स को, एक मैनेजर को कन्विंस करना. तो आई थिंक सर दिस इज सेम चैलेंजिंग जॉब विद रिस्पेक्ट टू द लाइक R&D जॉब. तो सर दिस इज़ ऑल अबाउट योर जर्नी. अभी टाइम आ गया है, हम अपने जो यंग एस्पिरेंट्स हैं इंजीनियरिंग कॉलेजेस में, स्पेशली आई एम टॉकिंग द Tier 3 कॉलेज, Tier 4 कॉलेजेस, जिन बच्चों को ये हमेशा डाउट रहता है कि हमारे लिए कंपनीज़ नहीं है, हमारे लिए अपॉर्चुनिटीज़ नहीं है, लेकिन मैं उनको समझाता हूँ कि आप लोग एक्सप्लोर नहीं करते हो, राइट? अपॉर्चुनिटीज़ बहुत है. एक छोटा सा डिवाइस है जिसको हम कई तरीके से यूज़ कर सकते हैं. ओके, HDL से, डिजिटल से, C से, what we call embedded C, and MATLAB से, and nowadays Python also, right? तो वो एक FPGA है. FPGA से पहले CPLDs आया. तो मैं चाहता हूँ कि सर थोड़ा सा आप हमारे बच्चों को आप ये बताओ कि हाउ दिस FPGA इवॉल्व. ओके, FPGA क्यों आया मार्केट में, ओके, और अभी करंट ट्रेंड क्या है, किस एप्लीकेशंस में हम FPGA को यूज़ करते हैं, एंड डेफिनेटली जो लास्ट क्वेश्चन होगा वो होगा सर करियर पॉइंट ऑफ व्यू से, कि हाउ दिस FPGA इज गोइंग टू चेंज देयर टोटली इंटायर लाइफ.
Right, right,
in terms of salary, in
mm,
terms of challenges, in terms of everything, sir.
right.
Yes.
So it was 1984, right?
Okay.
That is when Xilinx invented
Yes.
FPGA, right?
Yes.
It has been 40 years now.
Yes.
So this is a relatively newer technology compared to a standard semiconductor chip, right? IC was invented long before that. But FPGA, the fundamental reason why FPGA was introduced was to support the reprogrammability, field programmability, and flexibility that
Okay.
it brings in, right? So when you look at the kind of applications an FPGA can enable, it's a lot more applications compared to a standard fixed architecture chips like MCUs, MPUs, CPUs, or GPUs.
Here, I just want to stop you. Here, students, here reprogrammability means you can program your device not a single times, many times. Okay, and whenever you get the desired output, you can just go through and use for your product. Okay, so here sir
Absolutely.
has mentioned the reprogrammable means a device which you can program many times with the help of HDL,
Yeah.
not any other language, hardware
Yeah.
description language that we
Correct.
call initially Verilog and VHDL.
VHDL.
Yes, sir. Go
Right.
ahead.
So one is reprogram it, other
Yeah.
one is you can field program it.
Yes.
Right. In fact, we have even gone to a level where you can dynamically switch
Hmm.
the code on the runtime. We
Hmm.
call this as partial reconfiguration. You might remember.
Yes.
Now it is also called as dynamic function
Dynamic
exchange,
function.
where you can dynamically switch between two different images
Hmm.
on the same device doing completely different operation.
Okay.
Right. So that kind of flexibility is not available in a standard fixed architecture chip.
Okay.
Now the second thing.
आई वांट टू स्टॉप हियर सर. अगर हम इसको ऐसे कंपेयर करें FPGA को ASIC से
Yes.
या FPGA को प्रोसेसर से, ओके, तो आई थिंक आजकल के जो स्टूडेंट्स हैं दे आर अवेयर अबाउट अ माइक्रो प्रोसेसर, दे आर अवेयर अबाउट अ माइक्रो कंट्रोलर.
Correct.
तो ओके, हाउ दिस इज डायनेमिक देन an ASIC or any
Oh,
microprocessor
absolutely.
or
Yeah.
microcontroller?
So main difference between an ASIC
Hmm.
and an FPGA is that FPGA is very fluidic in the nature of the device itself, right? You can reconfigure it.
Hmm.
You can configure the way you want. It's in a simple analogy. ASIC is a paper with a pre-printed data.
Pre-printed, yes.
FPGA is a blank sheet of paper.
Yes.
Right? You can put what you want
What
on
you
that. Right? That's a simple analogy. But what is also important is when you are developing products which are used in standards which are still evolving, right? Classic example is telecom, right? 5G, 6G. Standards are still evolving, right?
Okay.
If you look at defense, there are many standards that continuously evolve. So when you go ahead with a fixed architecture chip like an ASIC based, you have no possibility of upgrading when the standards get finalized.
Yes.
So there also FPGA makes a huge difference.
Yes.
And the most important one, which I answer most of the students typically,
Yes.
is the making an ASIC in the
Yes.
current scenario. We are in 2024 and we are right now going below 5 nanometers towards 3 nanometers, 2 nanometers. Making a chip, an ASIC, is becoming very expensive,
Yes.
right?
You already mentioned, like,
Yeah.
it's required 4 billion
Yeah.
for a 7 nanometer.
Exactly.
Yes.
So if you're an R&D of a product like a 7 nanometer costs
Hmm.
billions of dollars.
Billions of.
So it is not very easy to build such chips anymore. And what it means is if you want to use a device in your system and if you have no option of building so much of capex, then I would rather use a flexible reprogrammable chip
Hmm.
and get done with my job. So there is of course advantage of ASIC,
Hmm.
but there are a lot of entry barriers of building an ASIC if you don't have the economy of scale, which
Yes.
is huge volumes,
Huge volume.
right? Every application may not have such volumes.
Hmm.
So if you don't have it, it is good to go with the alternate solution like an FPGA.
Yes.
And one last point on the FPGA is, which is inherent to the FPGA, is the parallel processing,
Parallel processing.
right? So there are a lot of applications that we are seeing today which requires extremely low latency, right? This can be in automotive,
Yes.
this can be in telecom
Telecom.
application, in defense applications,
Defense.
where you need to counter the
In space.
in space. So serial processing is not something that is efficient for such architecture,
Yes.
right? You need parallel processing, you need low latency, and what is most important, you need deterministic response,
Yes.
right? When I say I need the response within a certain period of turnaround time, FPGA is one of the ultimate device which can deliver that kind of a performance compared to any other ASIC.
Great, sir. You have a very you have a great depth in FPGA, but unfortunately, sometimes I really think that I am failed in giving such information to my students. But yes, तो सर about career point of view से ये कैसा है FPGA पर क्या क्या challenges, क्योंकि I know ये लोग जो स्टूडेंट्स हैं वो ये सोच रहे होंगे कि FPGA पे हम इतनी बात क्यों कर रहे हैं. तो मैं एक बात बोलना चाहूँगा कि बिफोर AMD, नाउ इट इज़ AMD, ओके. तो Xilinx को यूज़ करने वाले 2000 इन 2003-4 आई थिंक ओनली 3-4 कस्टमर्स. आई थिंक नाउ more than 35-40 customers.
Oh, a lot more.
A lot more. Okay. So the problem is that कि मैं खुद एक कस्टमर हूँ, FPGA यूज़ करता हूँ. Okay. Many of you know, okay, that I'm running an R&D organization known as OJS Technology. So our every product is on FPGA. Okay. मैं एक प्रॉब्लम फेस करता हूँ कि मेरे पास कभी ऐसे कोई बच्चे नहीं आते और बोलते हैं कि सर मैंने 200 लाइन का कोड लिखा है सी में, या मैंने वेरिलॉग में, या VHDL में. सर कैन आई गेट इंटर्नशिप अपॉर्चुनिटी? आई एम ईगर टू गिव दैम. तो सर यही प्रॉब्लम, आप पहले ये बताइए कि कितने कस्टमर्स हैं, नंबर्स क्या हैं FPGA के, FPGA यूज कर रहे हैं छोटे बड़े.
So this problem is universal.
Yes.
Not just in India, across the world.
Yes.
But more so in India.
Yes.
Right. Like you said, we have more than 200 customers in India who use FPGA.
200.
Yeah.
Sir, ये
Right?
मेरे से भी double triple हो गया.
Yeah.
Because I
So-
thought कि it is because I always quote 30-35.
Yeah. No, we have a lot of customers
200.
in India
Okay.
who use FPGAs.
Okay.
And that ratio is continuously growing.
Okay.
Right. Because remember, FPGA is no more just an FPGA.
Okay.
It is all becoming SOCs.
Okay.
Right?
Yeah.
So what we are also calling FPGA is a part of the SOC,
Yes.
and the main focus that we have today is called heterogeneous compute. Right? Heterogeneous compute is you don't use one type of a compute engine to run your application. You take your application, break it down into different sections, and see what is most efficient architecture to run that app.
Let's
subfunction.
make it more simple. Here heterogeneous means कि a single device, like in a team, like a person who knows the C.
Yeah.
Okay, they don't know the Verilog VHDL.
Correct.
Okay, so I make it more simple, sir. So he or she can use the FPGA.
Absolutely. So let us say you have you are building a simple system which requires some amount of serial processing, some amount of digital signal processing, some amount of low latency FPGA based processing. So then what happens? You all have heard of this device called Zinc. All the serial processing or control algorithms can run on the ARM.
Okay.
Right?
Yes.
And all the low latency application can run on the FPGA, which is the LUTs.
Yes.
Right? And then you have DSP slices which are also built into the FPGA, which can run the signal processing application. So what happens is these are different heterogeneous cores and different parts of the algorithm can run on these. So because of that, so going back to your original question, we have the same problem of lack of good FPGA or SOC engineers in the industry. I cannot tell you how many of our customers say we need good FPGA engineers.
Yes.
And there is one type of role which is always having vacancy in our customer base is actually FPGA engineers.
Yes.
Right? I have never seen a customer who says, "Oh, I have all the engineers that I need for FPGAs."
Yes.
Right? They always run short of good FPGA engineers. And let me take one more step. When you look at the domain that we are in, it is not just, let's say, people who are building systems, even chip companies, right?
Yes.
If you look at, yeah. So if you look at chip companies,
yes,
even AMD uses FPGA engineers. We have all our competitors who use FPGA
engineers. करना
engineers.
चाहूँगा जब मैं जॉब पे था, I used to support ST Microelectronics. ठीक है, I went NXP. Okay, उस टाइम पे ये दो थे. तो ये लोग अब जो भी ये लोग आईपीएस बनाते थे बेसिकली, ओके, मैं बच्चों को बोलता हूँ कि यू शुड फील प्राउड फर्स्ट थिंग कि ये जितने भी ये प्रोसेसर हैं, सेंसर हैं, ये किसी और लैंग्वेज से नहीं है। सबसे
Correct.
पहले ये वीएलएसआई के थ्रू जो हमें एक आईसी मिलती है
Yeah.
बेसिकली, उसके अंदर इतने मिलियंस ऑफ ट्रांजिस्टर्स होते हैं, वी कैन नॉट कनेक्ट इट मैनुअली।
Correct.
तो इसके लिए एक प्रोग्रामिंग लैंग्वेज के थ्रू एक कोड लिखा जाता है
Correct.
जो एक पर्टिकुलर एप्लीकेशन को मीट कर रहा है।
Correct.
वो हमको एफपीजीए से मिलता है।
Correct.
वो गेट इंफॉर्मेशन हमको एफपीजीए से मिलता है।
True.
और आई नो कि ये एक आरटीएल डिज़ाइन प्रोफाइल है जो हर वीएलएसआई कंपनीज में है। तो सर आप सिर्फ 200 मेंशन कर रहे हैं, यानी कि यहाँ पे तो 400 हो गए।
Absolutely.
FPGA
It will be more because there are a lot of, like I said,
हाँ.
prototyping and emulation,
Yes.
ASIC emulation companies. And what we have also started to see, you might have heard this program called Swadeshi Microprocessor Challenge
Yes.
that happened
IIT
in.
Chennai.
Yeah, this is IIT Madras,
the IIT
and
Madras, हाँ.
and also there were other organizations like CDAC and
CDAC
all
and
who are
others.
involved quite closely. So they actually ran a huge hackathon in 2020, 2021. And out of that, many startup companies came out, which all used FPGAs to solve real-world problems of India.
Yes.
Right? Today, I can name several of those. There is a company called Vanix Technologies in Hyderabad. There are a couple of companies in Chennai. There are a couple of companies in Hyderabad who also used to participate in this, and then finally started their own company. So, not just getting into another large company, we have seen people who are so curious and were so impressed with FPGA capabilities that they started their own companies around it.
Great, sir.
Right? So there are different ways you can have your career built on FPGA and SoCs. It can be, you can get into a system level design with segments like defense, aerospace, industrial, telecom, automotive. You can also get into companies which make chips, where you have you have emulation, prototyping kind of engineering opportunities, which all is based on FPGAs. The third thing, which my favorite, is start your own company.
Yes.
Right? What you did.
Yes, thank you. Yes, sir.
So there are so many young bright students who are interested in starting their own companies on FPGA based.
Easy है FPGA पे काम start करना as a startup, because as comparison to on VLSI part, because वहाँ पर आपको tools पे invest करना पड़ता है, और हाँ वहाँ पे engineers easily मिल जाते हैं, because इंडिया में मैंने देखा है कि as comparison to FPGA, okay, there are many बहुत सारे बच्चे हैं जो VLSI को समझते हैं लेकिन FPGA को नहीं समझते।
करेक्ट।
ओके, तो इट्स गुड सर। एक चीज़ जो अभी मिस कर रही है सर, हमने बच्चों को थोड़ा सा ये बताना है कि सैलरी के पॉइंट ऑफ व्यू से जो ग्रोथ है, बिकॉज आई थिंक जो सबसे इम्पॉर्टेंट है और जो सबसे मोटिवेटिंग है आज की डेट में, मैं जब भी किसी प्रेजेंटेशन में जाता हूँ मैं एक चीज़ पूछता हूँ कि मैं आपका एक इंडस्ट्री लीडर हूँ, आप मुझे बताओ कि आप मुझसे क्या जानना चाहते हो। सर 10 में से 9 बच्चे ना एक ही चीज़ बोलते हैं कि सर व्हाट पैकेज यू आर गोइंग टू ऑफर मी। तो यहाँ पर क्योंकि ठीक है, हमें ना कुछ अच्छे बच्चे हैं, कुछ एवरेज हैं, कुछ मीडियोकर हैं, तो हमें हर सेगमेंट में बच्चों को देखना पड़ेगा कि उनकी जो डिमांड है वो ठीक है, पैसा है, अच्छी बात है, सब कुछ चाहिए। तो उसके बारे में सर थोड़ा सा इस एफपीजीए इंडस्ट्री में क्या ट्रेंड चल रहा है?
सो व्हाट आई सी टुडे, most of the FPGA entry level jobs are very similarly paid compared to any software services jobs.
Okay.
Right? It's not much different at all.
Okay.
It's not lower at all.
Okay.
Right? But I keep telling about this curve, which you are also aware. When you are in a core engineering stream, be it electronics, be it civil or mechanical, any of those core engineering streams, it takes a few years to grasp the entire system level understanding before your value starts to shoot up, right? That typically happens in electronics also, and that's probably a period of 3 to 4 years at a minimum. Sometimes it can extend to 5 years depending on the kind of application you are working on.
Okay.
But once you cross that threshold, typically in electronic stream the salaries go exponentially high.
Okay.
Right? And I have seen this with many people. because the value add that you bring into these companies are extremely high once you have learned your art really
Okay.
well. So the suggestion I give it to students is, don't think that computer science segment or the jobs in computer science is any better. Electronics is really catching up, and I would also say now is the great time to be in electronics and semiconductors and VLSI. Looking at all the kind of investment that are happening in India around semiconductors, number of opportunities that are coming to India for semiconductors is way more than the software,
Yes.
right? It's way more. And second thing, probably it is going to take some more time for AI to catch up with electronics jobs than computer science jobs,
Yes.
right? It's not going to be easy for AI also to catch up on some of our jobs.
Yes.
So, having said that, I would still encourage students to look at electronics as the core stream, because over a period of time, the salaries are going to exponentially increase. And today, as we speak, we are almost on par with any of the computer science jobs.
ग्रेट सर, ग्रेट सर। इसी एआई से एक चीज़ याद आया मुझे। मैं आजकल वो चीज़ काफ़ी कर रहा हूँ। हर 10 में से 9 बच्चा, एवरी 9 कैंडिडेट्स आउट ऑफ 10, आइदर फ्रॉम सीएस, ईसी, इलेक्ट्रॉनिक्स, इलेक्ट्रिकल, मैकेनिकल, सिविल, बीसीए, एमसीए, एमएससी, बीएससी, सब पाइथन। everyone is running behind a python. ओके, 3-4 साल पहले या 2 साल पहले मैं भी सोचता था कि यार पाइथन चला गया, हमारे हमारे बच्चे पाइथन कर रहे हैं, मैं उनको नहीं कुछ सिखा पा रहा हूँ क्योंकि वो एचटीएमएल को कुछ समझते ही नहीं है। पर जब आपने पिंक इंट्रोड्यूस किया पाइथन ऑन एफपीजीए, जिस पे मैंने हैकाथॉन्स किए, और अभी आजकल मैं कॉलेज में जाता हूँ, बच्चों को दिखाता हूँ पिंक बोर्ड पे कि कैसे देखो, एक उनको मैं जुपिटर ओपन करके कोड लिखा हुआ है, ओके, उस कोड को मैं दिखाता हूँ कैसे आप जो वर्चुअल सिमुलेशन कर रहे हो और ये हार्डवेयर सिमुलेशन है। तो सर थोड़ा सा आप इसके बारे में, मतलब मैं तो शेयर करता रहता हूँ, बट आज आपके थ्रू जानने चाहते हैं कि इन बच्चों को बताना चाहिए कि जो उनके डोमेन में पाइथन कितना इम्पोर्टेंट रोल प्ले कर रहा है, और उससे वो करियर के पॉइंट ऑफ व्यू से कहाँ लैंड हो सकते हैं अगर वो किस तरह के प्रोजेक्ट्स कर लें।
Okay. So, absolutely. So, one of the reason why AMD Xilinx also introduced Python on Zinc is to make sure that we are on par with any of the other semiconductor chip related with AI, right? So AI is already caught up. It's huge surge of demand that is going on from last few years now, and it is going to continue for many more years, right? When you look at AI, there are two areas. One is the training, and the other one is the inference, right? Training is typically done on a GPU, but we are looking at inference with the FPGAs and SoCs. So if you are getting into inference, then typically these are low-end devices, which can be right at the edge, right, doing certain application, and this is a need of the hour in many segments, right? You think of defense, they are talking about cognitive imaging applications, smart imaging, smart cameras, things like that. You look at telecom segment, they are looking at self-healing networks, AI on the edge with radios. You look at automotive, there is adaptive or I would say driving assistance systems, or autonomous driving systems, which all require AI kind of application right at the edge. So to meet those demand, we looked at how do we get people to use our devices, because you need a low latency deterministic device, but at the same time you need some sort of a way in which you can access these devices much more easily compared to a very traditional hardware language like VHDL or Verilog. So that's where Python came in, and it gives you a easy design entry language compared to VHDL and Verilog.
Because Python में बहुत सारी libraries हैं, इसकी वजह से पाइथन फेमस है। तो और इजी है, बच्चों को भी लगता है कि ये प्रोग्रामिंग डोमेन है और मुझे ये CSIT से कनेक्टेड करेगा। बट उनको सबसे पहले अगर मैं जो रिकमेंड करता हूँ, जो मुझे आपसे बात करने पे पता चला कि why not we can ask them to design all the digital circuits first on Python.
So my suggestion and guidance to all the students is still Python on any of the FPGA is great, but you need to know what is under the hood, right? you need to know the fundamentals of digital
Fundamentals of
logic.
FPGAs, yeah.
How does the
FPGA work.
FPGA internals work?
Yes.
How does LUT work?
Yes.
How does block memory work?
Yes.
How does the flip flops that are connected to it work? What are the differences between these?
Yes.
Running simple applications like counters, shift registers.
Yes.
Those are fundamentals before you get into a higher level.
Yes.
Things like Python or AI libraries.
Yes.
When you are in the electronics domain, right?
Yes.
Because you are the one who are going to work under the hood.
Yes.
And the idea is all these applications can run on top of a layer, but if you don't know what is there and the hardware, you will not be able to debug when there is an issue,
Yes.
right? So always spend your time learning the basics, but of course, considering the demand in AI, it's great to have some knowledge of
मुझे
Python.
बस एक चीज़ चैलेंज यहाँ लगता है कि वर्किंग ऑन FPGA इज़ ऑलवेज अ कॉस्टली सोल्यूशन बिकॉज व्हाट आई फाउंड बहुत सारे बच्चे हैं जो अपने फाइनल ईयर के प्रोजेक्ट्स करते हैं दे जनरली डू ऑन ऑर्डिनो रसबरी एंड ऑल दिस छोटे से डिवाइसेज है ओके सो इट इज़ ईजी टू गेट इट बट
Yeah.
अ मिनिमम गुड क्वालिटी बोर्ड FPGA बोर्ड इज़ अराउंड 10K or 12K or 15K. I'm talking about basis. Okay, if they are getting from their own college ID. Okay, so एक challenge है, but ठीक है सर. We have to identify the good talent
Yeah.
from the bunch of engineers.
Yeah.
Okay, तो सर बहुत अच्छे से आपने चीज़ों को explain किया and just before closing this session, I just want to know in very brief कि what message you want to give to our young engineers. What?
Sure.
Yeah.
So I think my main message to all the students who are listening to this is semiconductors and the FPGA industry is growing in India with all the investment that is coming from government, from the private companies in India in this segments like aerospace, defense, industrial, medical, even telecom. There is a lot of opportunities that are expected to come in, and also the main thing which is behind all this is the semiconductor push that is happening from government. It's a great time to be in this industry, right? I keep telling what happened 25 years back in software in India is what is happening today in hardware in India.
Okay.
So jump into this. It's going to be a very adventurous, fun ride. Have faith in the core stream like electronics, and then build your knowledge, build your expertise. You are going to have a fulfilling career.
Great, sir. I want to quote one thing here. One of my good friend has always quoted me. No one can replace their father, and the father is a hardware. So no one can
Absolutely.
replace the hardware.
Yeah. So there is a very interesting saying from Steve Jobs. You would have heard this, right? People who are serious about their software build
Yes.
their own hardware,
Yes.
right? So if you are really serious about your software, if you say it is serious, then build your own hardware, right? You are going to
Great.
make a really good product out of it.
Great, sir. Thank you, sir. Thank you very much. So, students, I'm waiting for this podcast from long time. Okay, मैं चाह रहा था कि एक जल्दी से पॉडकास्ट शुरू करूँ, टेक्निकल सीरीज शुरू करूँ. ओके, सो ये मेरा पहला पॉडकास्ट है एंड आई स्टार्टेड विद वन ऑफ माय लाइक सीनियर फ्रॉम द इंडस्ट्री. ओके, और बहुत मोटिवेटेड था, बहुत एक्साइटेड था कि कुछ टेक्निकल चीज़ें अपने इन बच्चों को शेयर किया जाए सर. तो आपके थ्रू ये मुझे मौका मिला एंड आई एम वेरी हैप्पी.
Thank
तो
you.
मुझे एक फ़ील आ रहा है कि आपसे बात करके कि अपना जो इलेक्ट्रॉनिक्स डोमेन है, ओके, एक लाइन है जो मैंने पढ़ी है और जो मैं इसको कोट करता हूँ, बार बार बोलता हूँ, हम है तो दम है.
Absolutely.
दम है क्योंकि इलेक्ट्रॉनिक्स है. तो दिस इज़ व्हाट मैसेज आई वांट टू गिव यू पीपल. ओके, इलेक्ट्रॉनिक्स से प्यार करो, इलेक्ट्रॉनिक्स से साथ खेलो, जियो, जो
Absolutely.
करना है इलेक्ट्रॉनिक के साथ ही करो. ओके, बिकॉज इलेक्ट्रॉनिक ऐसा डोमेन है जो सबके लिए अपॉर्चुनिटी क्रिएट करता
Yeah.
है.
Yeah.
कुछ सालों पहले एक प्रोसेसर ने कैसे इतनी मिलियंस ऑफ जॉब क्रिएट की. मेरे पास, आपके पास फ़ोन है, उसमें
Yeah.
40 से ज़्यादा ऐप्स हैं.
Correct.
ओके, वाई दिस ऐप. ओके, ये ऐप पहले नहीं थे, आज से 10 साल 15 साल पहले सर. तो एक प्रोसेसर ने इतनी अपॉर्चुनिटीज़ क्रिएट की.
Correct.
तो इसीलिए मैं सर इस चीज़ को बोलता हूँ कि द बेनिफिट ऑफ हैविंग एन इलेक्ट्रॉनिक इंजीनियर इज ऑलवेज बेटर देन एनीथिंग.
Absolutely. Electronics, semiconductors are going to be omnipresent,
Yes.
right? If you look at how world will be in the next 10 years,
Yes.
you will find electronics almost
Yes.
in every possible thing,
Yes.
which is already happening, right?
Yes.
You can find chip in almost everything.
Yes.
That means it is omnipresent, and
Yes.
it's going to only going to increase.
और बिफोर क्लोजिंग सर, मैं ये भी ऐड करना चाहूँगा कि ऐसा नहीं है कि हमें दूसरे डोमेन्स की ज़रूरत नहीं है, वो भी हमारे, उनके बिना हम नहीं हैं और हमारे बिना वो नहीं है, क्योंकि हार्डवेयर तो हम अच्छा बना देंगे, बट जीयूआई तो, और
Yeah.
वो एक इंटरफेस
Yeah.
तो सॉफ्टवेयर डोमेन ही डेवलप करेगा, तो दोनों लोग ही इस टेक्नोलॉजीज
But there needs to be a balance, you know. Whoever is interested in this core
इन
field,
दिस कोर.
don't leave the field,
यस.
right? Because there is so much opportunity,
Yes.
and opportunity is actually coming in now,
यस.
right? It's a great time to enter.
नहीं सर, आपने एक नंबर कोट किया 200, मतलब आप जस्ट सोचिए सर, आई एम जस्ट टॉकिंग, इफ आई हैव 10 इंजीनियर्स ऑन FPGA साइड, then how many opportunities for them?
Oh, absolutely.
10 and 12 companies.
Yes.
Okay, so I need to generate at least 1,000 engineers in a,
We need more.
in a
We
year.
need even more.
In a year.
No, we need
Oh.
even more. If you expand from FPGAs to VLSI,
Huh.
I think it is going to be in thousands that we
Okay.
need.
Okay, great sir. Thank you very much sir.
Thank
It's
you.
a great session with you sir. Thank you.
Thank
very
you so much.
Thank you.